Me at the back? Everything good? Okay. My name is Raj Gill. We're going to get started with this session. Welcome to NextGen scalable and highly available design architectures. Just a little bit of background on myself. I spend a lot of time as the CTO of Scalability Experts. Prior to starting co-founding Scalability Experts, I was part of the SQL Server team at Microsoft. Worked a lot in the with customers, helping them deploy SQL Server. I spend a lot of my time working with customers, helping them design architectures that are highly scalable and highly available. And my goal today is to kind of bring to bears to you some of the things that we have seen that have worked for us in the real world. Okay, I'm sure everybody here is responsible for some sort of a production SQL Server, right? Everybody, right? So you are kind of facing the same challenges that we see with our customers. So what I wanted to do is put together this session that is, and we're going to talk a little bit about some very specific technical features as well in SQL Server 2008 R2. So let's get started. The agenda is we're going to talk about the data management challenges. Okay, and I'm sure that a lot of you can relate to what I'm going to talk about. This is what customers are facing today in managing the data. There was a recent Gartner study that came out that said that in the amount of data the companies are generating in the next 5 years, or will generate in the next 5 years, is going to be greater than in the last 50 years. Okay? Everybody's shaking their heads, right? You know, the days of 1 terabyte databases are gone. We're talking about tens and hundreds of terabytes of data that you are going to be managing and you are responsible to manage. Now, what that does is you don't need to be a rocket scientist to figure out that a query that takes 2 seconds on a 100 GB database, given all things being equal, is not going to take 2 seconds on a 10 terabyte database, right? Or 1 terabyte database, right? So what do you have to do? You've got to understand what the challenges are. What are the key technologies? Okay, how many of you are responsible for the SQL Server database and the infrastructure that sits underneath that? Right. Very good. Very good. A lot of times you have kind of the DBA role and the infrastructure role separated. But I'm seeing a trend where a lot of customers see synergies and getting these two groups to work together more closely, and that's really good. So, you know, in the old days, I call it the old days because, you know, there's a shift in paradigm that's going on, right? Whenever there's a performance problem, what's the number one thing that's blamed? Database, right? And who does the database guys blame? Developers, right? It's the code. Yeah, you're killing my SQL Server. Why are you writing some bad code, right? Guess what's the change in the paradigm? It's no longer the database. It's no longer the applications. It's the architecture. It's the design. Okay? So that's what you have to think, because the business is changing so fast and so rapidly that there is no time to finger point. There's no time for you to say, hey, you've got to take the time to change all the code that you're writing. And here's the top 20 queries that are bad, by the way. And it's going to take you a whole year to figure out how to write better code, right? The business is changing so dynamically that it is incredibly important that you are on top of things. I was reading a case study on Starbucks. Everybody knows, well, how Starbucks went through a big disaster, and now they're kind of coming around. And they had an interview with the CEO of Starbucks, Mr. Schultz, and he said that the number one reason why Starbucks went through such a downfall was they did not have access to the data in a real-time basis. They did not know how the stores were doing. They did not know how their business was doing. And it's all about gobbles and gobbles of data these stores generated. They didn't know which stores were making money versus which were losing, and which products, and so forth and so on. So they spend a lot of money in making sure that they have the right infrastructure, the right technology stack, so their business can make those decisions. So guess what? Your world is going to change if it hasn't already. Right? You're going to get a call and say, hey, we want this data that's sitting in this database real-time accessible so we can make decisions. So you don't have time to tell somebody, hey, you got to write a better code, or I need a bigger box. Well, how are you going to solve that? You're going to have to build an architecture that is scalable and highly available. The other thing that's changing also is that, you know, oftentimes when you come to these sessions, like these conferences, you know, there's a lot of excitement around SQL Server features. Everybody wants to know what are these new features. But there's very little time that is spent on how do you take these features and apply to solve your business problem, right? Now let me just do a quick poll here. Does anybody know what was the #1 feature that got the most applaud when SQL Server 2008 was launched in San Francisco? It's a database feature. Anybody? Governor. Okay? SQL Server Resource Governor. Right? Got the most applaud. How many of you use SQL Server Resource Governor? Okay? See? This is what I'm talking about, right? So we're talking about all these features that come out in products, and how do you apply those? So hopefully we can take away some of those things. So what I want to do is I want to talk about the technology stack. I want to talk about those features that are a must. You must have these features. And I'm not just saying because I like these features. I'm saying it because we have implemented a number of these highly scalable, available designs, architectures for our customers, and we have seen tremendous results. And if you're interested in any case studies that is related to your industry, by the way, whether you're in retail or you're manufacturing and you want to say, hey, I want to talk to my boss about this architecture, cool architecture you talked about, can you give me some references? I'll be happy to give them in private. I have my business cards. My email is available to you guys. You can reach out to me. So this is, we've done it, and this is proven architectures. And then I've got, I want to spend some time discussing some reference architectures, okay, that hopefully we can all discuss as well. So what are the data management challenges? And if anybody has any questions, feel free to obviously raise your hand and ask. How do we gain significant scalability, availability while reducing the IT costs? Okay, the cost has to continue to go down 24/7. Okay, oftentimes I see a lot of DBAs make this mistake, is where they build a system and they don't realize that the business requirements can change tomorrow, right? So while they can consider that it's not a mission critical system, it only takes a phone call for your boss or an email to say, hey, by the way, this system is 24/7 from now on. Oh, wait a minute, I don't have a cluster. How do I build a cluster now? Or how do I make sure this system doesn't go down, right? So those are the things that always come to mind. Virtualization, how do I do it right? How many of you are using virtualization in production? In production. Okay, some of you are. Virtualization is something you must consider. You must consider. And a lot of things have changed. We're going to talk about that. Shared services architecture. This is the first generation of the cloud. Okay, shared services architecture has been around since the mainframe world. Okay, it's nothing new. But shared services architecture is the first generation of the cloud, the private cloud, and now we talk about the public cloud. Okay, we're going to talk about that. Scale up versus scale out. Here's another scenario where a lot of customers are very attracted to scale out. Why is that? Cheaper, low-end boxes, throw these quick, very easy to bring them up, boom, you're up and running, right? Low cost, business loves it. Guess what? Over time, it becomes a real problem to scale, to make sure it's highly available, the patching and all the maintenance and the backups and things that you have to do with it. So you got to really think about, is scale up the way you're going to go, or scale out is the way you're going to go, right? Hardware evolution, 8 core chips coming out, already out there, right? Anybody remember the first time hyper-threading came out? It was exciting, right? Oh, I'm going to get 2 processors for one. Now you can get 8 for one socket. And SQL Server, by the way, only charges you by the socket. So it becomes very attractive from a business value perspective, right? Customers like that. Now, when you have these boxes with 8 core CPUs, okay, you can't no longer go with these low-end boxes. You got to make sure you are making the most use of these machines, right? So you got to design your architecture around that. Monitoring and governance is very, very important when you're building a highly scalable system and highly available system. So there are a lot of these issues that are data management challenges that we can consider. Now, why are these pain points? As I said, next 5 years, there's more data that companies are going to generate than the last 50 years, right? Server sprawl. Data centers are running out of floor space. You can't add enough servers out there, right? And every time you add a server, the cost of maintaining and managing that environment goes up. Lack of a database strategy, right? So there are a lot of these reasons for the pain points. So what's the traditional architecture looks like in the SQL Server space? So traditionally, what has happened is a new application rolls out. I buy a new box, throw SQL Server on it, and it's a dedicated box for that server, for that application. How many of you agree with that? Traditional way to do things, right? Easy. I don't have to, mess around with convincing my management or anybody else. People like it. And by the way, you have 100 apps, you have 100 servers. 1,000 apps, you have 1,000 servers. I've been in customers where I was on a call and there were 3 DBAs and we asked a question, say, how many SQL servers do you have? I got 3 different numbers and the lowest number was 1,700. So you lose count of how many SQL servers. It's like it's sprawled. It keeps growing in your organization. But at the end of the day, you are responsible for them, right? Your job lies on the fact that they're running fine. Then when they come and everything gets dumped into your lap, saying, "Hey, you got to manage these SQL servers." So what do you have to do? You've got to build these architectures and designs that are highly scalable and not prone to this server sprawl problem, right? So one application, one database is the traditional database architecture, and there are a lot of issues with that. If you look at the database workload, the database workloads are also getting very complex, right? You have OLTP, you have reporting, you have batch processing, you have end of the month, you have quarter end, you have weekly batch jobs that run, and you have all these maintenance that you have to run now. So if you have a 24/7 system, guess what? You are going to run maintenance while there's production activity. You don't have a choice, right? If you have an international application that services globally, there is no weekend. Guess what? When there's weekend here, there's somebody else is working somewhere else, right? For example, in the Gulf, Saturdays and Sundays are working days, right? Many other countries. So you've got all these dynamics that you have to deal with. So when are you going to do maintenance? How are you going to make sure your server is healthy, right? You're going to take care of it. So the workloads are getting more and more complex. Each production environment most likely has a mix of all of these different workloads. The other big issue you have is when you add these workloads, you have this read-write contention. Read-write contention is one of the biggest bottlenecks that SQL Server databases, or in fact any database, Oracle or Sybase or whatever else you want to call it. And why is that? Because first of all, it creates blocking, right? Now we have some ways to work around that. Secondly, it creates I/O problem. If I optimize for heavy reads, I lose the optimization on writes. If I optimize for writes, I lose my performance. I get a performance hit on my reads. So what do I do, right? So you have this read-write contention that creates a challenge. And always there's a code, right, that you have to worry about. And the DBAs don't end up owning the code, right? Somebody else writes the code. And a lot of the ISV apps, one of the most horrendous codes I've seen is from these ISV apps. It's amazing. It's like 6th grader writing T-SQL. You have all these joins and you've got all this stuff, select star and all this stuff that you don't want them to do, they do that, right? Anything that's not on the best practices list, you'll find in an ISV app, right? And then you can't do anything about it. But that's the real world. That's the challenge, okay? There's the paradigm shift I'm talking about is it's no longer the database, it's no longer the application, it is the design and the architecture. That's where you have to focus on, right? Okay, and Microsoft isn't talking about cloud, right? What is the most important premise of a cloud? A cloud is a shared hardware and database environment. It's a shared environment. Nobody cares what happens once you provision a database and disk space, and you have number of users, CPU and memory. How that gets done behind the scene, nobody cares, right? That's the whole idea behind cloud. Whereas what has been happening with SQL Server? Every application goes on a server, right? And so you got to think about cloud because that's where everything is going. And the fundamental principle of a cloud is you got to build a shared architecture, shared services architecture, right? You got to have a set of SQL servers that are servicing multiple applications. Some of you are doing that with consolidation, with virtualization, and we're going to talk about that. So what are the key references? At a very high level, I want you to keep these in mind as we're talking about this session today. So virtualization farms. Virtualization is here. It is the future. If you haven't adopted virtualization, you must. Every architecture you're going to build, you've got to think about virtualization. It's ready for prime time. It's no longer, okay, I can't do it in production. Customers are doing it in production. It's come a long way. Now, it still has some limitations, don't get me wrong. I'm not saying just make everything virtualized in production, right? So it has some ways to go, but it is significantly improving, and you got to consider that. Scale out, read-only forms, okay? Traditionally done through replication. We're going to talk about some cool options that are available. Active, passive cluster. You have also disaster recovery systems, and then you have the cluster and virtualization hybrid. And this is where everything is going, and that's what we're going to talk about, is the whole hybrid model, how you could leverage both clustering and virtualization. Now, what are the key technologies and features? Okay, if there's any takeaway I want you to take from this session, is this slide right here. Okay? When you're building a reference architecture, you must look at going to SQL Server 2008 R2 and Windows Server 2008 R2. Because from a clustering perspective, the entire clustering stack has been completely redone. Completely redone. If you build a cluster on SQL Server 2008 and you want to go to 2008 R2, you're going to have to rebuild that cluster. Okay? There is no upgrade path. So the best thing is you got to get SQL Server and Windows 2008 Server R2. I know a lot of you are challenged with the fact that there's supportability within your department and how well these versions are supported. But if you're building a new design, a shared services architecture, a private cloud, please always have that on this stack. This is the kind of the building stack for you. Hyper-V or VMware, they are all supported, and they're the versions that are supported. There's a link I'll share with you. Live migration and vMotion. How many of you are familiar with live migration or vMotion? Okay, very good. So this is a technology that is available through virtualization only. Now, it still has some limitations. For example, VMware's vMotion only supports one CPU, right? So you can't throw every app that can do vMotion. But these limitations are being removed very soon. In a few months, the multi-core VMs will be supported with vMotion. So what live migration and vMotion does, it allows you to fail over a virtual machine without losing connections. Okay? What are the drawbacks of a cluster? What happens in a failover in a cluster? You lose the whole SQL Server goes to recovery, right? So when it goes to recovery, all the connections are lost. They have to be reconnected. And sometimes if you have a rollback transaction, it can take a long time to recover the database, right? So vMotion and live migration removes that to a large extent. So these are technologies out there. They're available today. You can tap into it, and you've got to make that part of your architecture design. From a SQL Server perspective, resource governor must. And I talk to a lot of DBs. So why don't you use resource governance? Like, well, I just have we have dedicated SQL servers. It's a management issue. I'll show you a quick example where at a minimum, you can have ad hoc users completely blocked out of your system, okay? Or limited in a way, because there are certain users who are going to cause you pain, and you want to make sure there's some level of resource governor implementation. Table partitioning, must. I've looked at over the last 8 or 10 years, I've looked at probably hundreds of databases. And there's a query I always run, which goes out there and says, okay, break down all the tables by size. And guess what? It's always consistently the top 10 tables take up 80% of the data. I've run this against database schemas that have hundreds of tables. And it's the top 20 or top 10 tables. Does everybody agree with that? Those tables must be partitioned. No questions. You must partition them. By date time, by ID. And there are a lot of advantages you're going to get out of partitioning. I'm going to talk about that in a little bit. And then you can also use compression. Okay? I'll give you a very simple example here. If you take a table that has 100 million rows and you run a query against that table. Now remember, the paradigm shift is you don't control the code and you can't blame the database. So your architecture has to accommodate all these problems that are out there. Right? So you have a query that does a join amongst multiple tables, and this one table, which is your biggest table, doesn't have the appropriate index. The query only returns 10 rows, but it ends up doing a scan on this table. Okay? So in SQL Server, once Microsoft introduced partition, the biggest granular component of data is the partition. So in SQL Server 2008 R2, the optimizer is aware that your data sits within a partition. So a partition is a table within a table from an optimizer perspective. Does that make sense? Right? So if I don't have any partitions, guess what? The optimizer says, hey, I got to do a table scan, and it scans the entire table. But if I have partitions, the optimizer says the most I have to read is partition 1 and partition 3. And it can parallelly read those partitions and retrieve that data for you. So by nature of just having partitions, you have reduced the cost of that query without touching the code, without doing anything, any indexing. Right? Now on top of that, you have the ability to do compression. You can compress data by partition. This is another discussion I have with my customers. Why are you not using compression? Well, we are analyzing. We have a whole POC around whether compression is really beneficial to us. We got to, we know this space will be saved, but we're worried about overhead and so forth. Well, if you know which are your large tables, and you know the queries that are hitting those tables, partition those tables, and compress the partitions that are most often used. Because by compressing the partitions, you reduce the memory usage and I/O usage by over 50%. Over 50%. So what I've just done, I've not changed any code. I've not done any changes in my indexes. I put partitions and I put compression, and I've reduced the cost of that query to a degree of probably 80%. Okay? How many of you would like to improve your performance by 80%? All right, so these are some things that I want you to take away that you must consider. Plan guides is another thing. We're going to talk about plan guides as well. And then, this is a very cool feature in SQL Server 2008 R2. Only available in R2, called the Utility Control Points, UCP. So there's this concept of extended events. And Utility Control Point is nothing but a management studio component that allows you to take all the performance metrics from different SQL servers and monitor and set up thresholds. Okay? So you can better control the usage of the SQL servers within your environment. When you build a shared services architecture, the concept of UCP is very, very important. Okay? So my recommendation is take a look at this. And by the way, there is a session Friday, I don't know how many of you are sticking around, by Roger Walter that's going to talk more in detail on this particular topic. But you can always get recorded sessions that are available from past. Okay? Now, key virtualization support facts. Guest OS with SQL Server 2005 and 2008 and R2 is supported in a cluster. So you can have a Windows cluster, and you can have guest OS that could be part of a cluster node or not that are running SQL Server 2005 and 2000. Anybody running 2000? SQL 2000? Sorry. I knew there were going to be a few that were on SQL 2000. But you have to be on SQL Server 2005 or 2008. Live migration support is available for SQL Server 2005 and 2008 and R2. But you must be running Windows Server 2008 R2. Okay? Hyper-V. So Microsoft virtualization is required here. So there's also quick migration. And I'm not going to read the whole thing, but the key aspect is live migration is where the entire VM fails over real time. Okay? Within a second, you can bring all your connections are pointed to the second node, and the queries can start executing again. Whereas quick migration takes a little bit more time. So make sure that you understand the difference between the two. Both are supported in Windows Server 2008 R2. Okay. Again, these features are available with some limitations. So if you have a very high-end application that requires multiple processors, lots of memory, you probably wouldn't be able to run that in a vMotion or live migration scenario. There is the link for virtualization support. So Microsoft has come up with the server virtualization validation program. Anybody remember the hardware compatibility list for clusters? Remember? So when clustering first came out, Microsoft said, hey, if you want to run cluster and you want us to support it, you must be running on the hardware that we certify. right? So same concept is applied for virtualization. There's flavors of VMware that is supported in production. There are flavors, obviously, of Microsoft virtualization technology that's supported. So go to that link and take a look, and it'll give you all the information of what VMware version, on what OS, and things like that are supported. So you can actually be on a supported platform. If you are doing virtualization in production, I would highly recommend that make sure you're on a supported platform, so you can get proper support on that. Okay. Another thing that's changed in Windows 2008 R2 is you don't require hardware that is on the hardware compatibility list. So you can actually do clustering with hardware that is a little bit disparate than what was required before. So there are quite a few changes that have happened on the clustering side. So shared services architecture, let's talk about that. So in a shared services architecture, you have your sales, you have your accounting, all these different applications, and then you are consolidating them into a single server within an instance, or they are databases within a single instance. So these little boxes at the bottom, these could be instances of SQL Server, right? Or they could be databases within one instance, depending on what the requirements are. Now, there are some challenges with this architecture, right? Whereas if I want a different patching mechanism for accounting than everybody else, then I have a problem, because I've got SQL Server running on the same box, right? So that's to overcome that, you can actually build a so this is a non-VM shared services architecture. So all these different boxes on the top, this is where you are currently. There are different utilizations, and you are consolidating them into as instances, and you're using the resource governor to grant the allocation of CPU and memory to each of these instances, or each of the databases within those instances. Okay? So let me take a look here real quick and show you the concept on the resource governor. So essentially, in SQL Server 2008 R2, if I go under management tree, I have this option of resource governor. Now, prior to 2008 R2, I had to actually, the only way to create resource pools and resource groups was to actually to do it through script. So now I can right-click on resource governor, and I can say I want to create a new resource pool, right? A resource pool is nothing but a bucket where you allocate a certain percentage of memory and CPU for that particular pool, right? So this is, I would, if I want to call this high usage. So high usage, I can grant a minimum CPU, or I can grant a maximum CPU of 80%, right? Also, I can say minimum memory and then maximum memory for that particular pool, right? And then I have to assign that to a group. So this is my heavy users, right? And I'm going to give it a high priority. And maximum, these are maximum requests. So this is another good thing, right? So for example, I have a resource pool that's created called ad hoc. Okay? So this ad hoc is the ones that I don't want to come into my production server and cause me problems, right? These are the ad hoc users, just logging in from any utility and then connecting. So and running queries. So what I've done is, for ad hoc, the maximum CPU is 10%, and the maximum memory is 10%, and the priority is low. And if you notice, the maximum requests, these are maximum concurrent requests that can come from these users, is 2. Okay? So what I've done is I say, hey, at a time, I'm not going to allow more than 2 ad hoc users concurrently running. Now, everybody else gets queued. Okay? They're going to be in waiting stage. So there's an effect for this, right? And then you also have some settings over here that says degree of parallelism. Okay? Degree of parallelism tells SQL Server how many parallel threads it needs to use for a particular query. So you have these ad hoc users who come in and run a big report, joining data over the last 6 years. Guess what that's going to do? It's going to saturate your CPU. But what you can do is set degree of parallelism to 1. So you say, hey, I don't care how big of a report you're running, you're only going to get one thread to process that query. Okay? So, yes, question?
Can that override a max POP setting on the query?
Yes. So the question is, if I set the degree of parallelism setting in the resource, in the work group, does that override if I also hardcode in the query a degree of parallelism of, let's say, 2? The answer is yes. So when that query comes in, and when the classifier function kicks in and says, hey, you are in the ad hoc pool, everything else is overwritten. Okay? And that's the beauty of this, because this gives you full control on your SQL Server. So, yes?
So when you set it to 1, are you talking about per CPU or per core 1 thread, or overall 1?
When we set it to 1, it's overall 1.
If you have 10 CPUs, only one CPU with 1 thread will work.
What this degree of parallelism does is basically disables the whole parallel query generation, parallel plan generation. So it becomes a serialized plan. Okay? So you have one thread that's executing the entire query. Okay? So it's not about CPU. Yes, question?
So that means so you're going to allow 2 ad hoc queries at any given time, right? So they're going to use each going to use 1 CPU.
Yeah. So if you have 2, so 2 are allowed, so each one will use 1 thread, so that means they can use 2 CPUs at a time. Correct. But remember, I also have a max of 10%. Okay? So they can use 2 processors, but they cannot use more than 10% of the total processing capacity that I have. Okay? So there are thresholds that are available. So anyway, what I'm talking about here is I can go into my GUI, create a very simple resource governor. A lot of DBAs I talk to say, we haven't really looked into it. What I'm saying is that if you're building a mission critical, the next gen architecture, it must have resource governance. Without resource governance, you're driving blind. You don't know what's going on in the system. You must put controls. Because guess what? You have no control over that ad hoc user that's sitting in some department accessing your database through another interface that you don't control, right? So what you can do is say, hey, my mission critical application queries are going to get most of my resources. Everybody else is going to by default sit in this group. That's only going to get 10%. I know you're not going to like it, but I want you to call me so that I can understand your requirements and give you or put you in a different pool, right? So this is not about making this whole resource governor project more complex. What I'm talking about, just put some basic controls in place, and in 2008 R2 you have a very easy way to do that. So you can also, by the way, script it out. So I can script this whole thing into a query. Let's see. I think I just a different makes it up here.
To create it to generate the script.
Yeah, so I am actually here. This is the one I was creating. I hit that on the wrong screen. So if I script it out, this is the script that it generates. So create resource pool, name of the pool, minimum CPU, max CPU, and so forth and so on, and then I create a workload group, and then so resource pool and workload groups are the 2 components that I've created. Now what do I have to do? I have to create the classifier function, and the classifier function basically says when a connection comes in, which pool does the user go into? And you have a lot of flexibility in that. You can say, hey, the classifier can say if it is between 8 a.m. and 5 p.m., my business hours, I want these type of users added to these type of resource groups, right? Or you can use the user's username, the database they are connecting into, the application name that they're connecting from. So there are a lot of different functions you can use to say how does your workload gets divided, okay? Who gets what? So this is, I think I might have an example of the resource classifier function. Let me take a look. Yeah, so basically it looks something like this. And again, there's a lot of examples in books online as well. So create function, name of the function, and then with schema binding, and you base this classifier function basically classifies users by the time of the day. Okay, and then once you create your classify user function, then you would basically do alter resource governor classifier function, and you would specify the classifier function to what you have just created. This classifier function must be created in the master database. Okay, it must be in the master database. So once you have done that, you can turn it on and you can turn it off too. So let's say that you have you have created an ad hoc user workload group, and for some reason the CEO of the company is accessing the SQL Server database using an ad hoc tool and falls in the 10%. Obviously, he's not very happy, right? What's going on? It's taking too long for my report, right? You can disable and re-enable the workload groups without restarting SQL Server. That's the beauty of this. You don't have to touch SQL Server, don't have to restart any of this stuff, and you can dynamically disable the entire resource governance and then enable it once you have made all the changes. Okay? So it's very, very cool, and I would highly encourage you to play around with it and use it, hopefully. Any questions?
Yeah. You have a table reference, and as far as overhead of selecting from that table in your classifier function, at least the best practices that I've always seen is to avoid anything other than local deterministic functions and not select it from tables and things.
Yeah. So the question is that if you are within the classifier function, you want to keep your code as agile and as minimal as possible, because every time a connection comes in, guess what? The function has to be executed to evaluate which resource pool the user belongs to. And if you're referencing tables, it can take a long time. Now, as long as the table is a small table, it's not expected to grow significantly large with hundreds and thousands of rows, I think you're fine. But typically, you want to probably do most of in-memory operations, right?
I mean, putting it all in the function means you're constantly having to alter the function. Putting in a table is a lot more flexible.
Yeah, absolutely, absolutely. There are many, many different ways to do this, and that's a good point. So now we're talking about shared services architecture using virtualization. Okay. So the previous design was non-virtualized. So here what I'm doing is I'm basically having different VMs, right? Now, if you notice, here I had one box, and I could on one box add all these different instances and accommodate and consolidate all these instances in one server, right? But when I do virtualization, there's overhead from virtualization as well, right? So I can't really squeeze everything as much as I want to. So typically when you do virtualization, you'll end up actually spreading the load into maybe 2 machines, right? Now again, it depends on how much resources are required by each application. So, and you can have a VMware and Hyper-V dedicated servers. Again, most of the companies, they either do VMware or Hyper-V, either or. But these are all virtualized VM machines running on these boxes. Okay. Now, another thing I had on my a must-use feature is a peer-to-peer replication. Now, this was introduced in SQL Server in 2005. So, what's the idea here? So, when you're looking at a multiple site application, right? You want an active OLTP. Peer-to-peer is the best way to get it done. So what it does is it allows you to have 2 sites, multiple sites, sending replication, bidirectional replication to each other, and it is significantly improved in SQL Server 2008 R2. I would not recommend this. I would have not recommended this when the feature was first released. But it is highly mature now. And for example, in the previous versions, if I want to add another node, so let's say in this example I have a server that is processing all the queries from the west region. I have an east server and a south, right? So if I want to add another one, let's say north, a server that's dedicated to service all the users in the north, what's going to happen? I had to rebuild the entire replication. Okay, and this is the problem of feature that is 1.1, right? It comes with a lot of limitations. So now I can dynamically add a node, and it starts receiving all the changes, right? And the other problem I had in previous versions of SQL Server prior to R2 was that there was no conflict resolution. So if somebody changed a row, the same row in two different servers, I had a problem. Which change do I take? So now there's conflict resolution built in peer-to-peer. Okay? So the reason I'm talking about this so highly is that because this works really well. Okay? And you can actually have read and write active instances of SQL Server that send data by. Anybody using peer-to-peer? Anybody? What has been your experience with it? Good? Good. Excellent. Excellent. So, and I have a demo, a recorded demo on peer-to-peer. I want to show you how easy it is set up in SQL Server 2008 R2. If we don't get the time, I can send you a copy of the demo. So that way you will have it and you can kind of walk through that, okay? So as I said, it was introduced in 2005. A lot of things are significantly improved in it. It's based on transactional replication. You have conflict detection now, insert, update, deletes. Also, if you have store procedures, you add store procedures, those are replicated. All the schema changes are replicated. So you have all these, all the things that a transactional replication does are replicated in this scenario as well. Scalable shared databases. So these are read-only databases. Anybody using OLAP databases, data warehouse? Okay, so very useful for those. If you're using analysis services, you can have read-only databases available for your users. So the way it works is you have your cube, and the cube is constantly being refreshed, right? And then you detach and attach the cube over to your production. And then you have all these different servers that act as memory and CPU cachers. Okay? So you have one copy of your data warehouse cube, and then you have all these different servers that are accessing that same copy, and it's only for read-only purposes. So if you want to take a copy of your OLTP data and provide it as a read-only copy, this is a great architecture that you can use. All right, how do we build a OLTP and reporting farms? So you have your web layer, and then you have your data access framework. So you will need a data access framework. It's a fancy word for nothing but something that tells, when the connections come from the web, something that says, okay, where should this particular connection go to? Which SQL Server instance, right? So when you build a peer-to-peer replication model, okay, if a user is coming from the west region, somehow you detect that this user is from the west region, and then it gets pointed to that appropriate SQL Server that is servicing the west region, right? This is not a load balancer. It could be like a table sitting in SQL Server or a text file, or it's a concept of mapping an IP address to a server name. So some customers use an XML file. Some use it as a table within a SQL Server that's sitting on another environment. So, yeah. All right. So what you have here is you have an OLTP farm. You're using peer-to-peer replication. So what's happening is all SQL 1, SQL 2, SQL 3, SQL 4, all the changes happening on each one of the machines are replicated everywhere. It's all bidirectional. Okay? So for example, if I want to do maintenance on SQL 4, I want to apply a SQL Server patch. Right? So think, for example, in a cluster, what is your single point of failure? In a Windows cluster? The disk, because it's a shared disk. The second? Well, I can have redundant network. Well, it's the SQL Server instance itself. Why? Because when you apply a patch, you can't fail over that instance. You've got to take that instance offline. That's the only way you can apply a patch to it, right? So here what I can do is I have got multiple copies of SQL Servers, that same database running on these machines, right? So SQL 4, I want to apply a SQL patch. I take it offline. So what do I have to do? I have to go into my data access framework, and I say, hey, whatever connections were going to SQL 4 are now going to go to SQL 1, 2, and 3. Spread it out, right? SQL 4 is off. You apply the patch. You bring it back online, and it starts receiving all the changes from all the other 3. And once it's up to date, it can then be accepting new transactions, right? So this is a great way for you to build read-write active copies of your SQL servers. Does that make sense? Okay? And it's very, very good. I would highly encourage you. It's a highly mature feature now, and it works really well. And the biggest challenges with peer-to-peer was setting it up, taking a node out, adding it. You had to take a lot of overhead with it. Now it's all smoothened out in SQL Server 2008 R2. And then what I can do is I can use database snapshots to build read-only copies. Okay? I can use database snapshots to build read-only copies from those. So I have, in this example, I have a web layer, I have a data access framework layer, and I have a SQL Server OLTP read-write layer, and then I have a read-only layer. So I've got all the different components built in. Right? Database snapshots. So let me just talk about this. Database, how many of you are using database snapshots? Okay. How many of you have a problem of blocking which is directly related to readers and writers? Same, I would think more people would have this problem. Okay. Well, so you have a classic issue of read-write, right? So you have readers and writers, and you have row versioning that's available in SQL Server. But in row versioning, it comes with an overhead, right? So I have and typically where database snapshot is such a great feature is, let's say you have a batch job that runs every so often. It's a read-only job, data extraction or data manipulation, whatever it is, right? It goes through your big tables, and every time that job runs, it starts causing blocking all over the place, right? And you want to completely avoid that. Database snapshots are a great way for you to do it. And let me just show you that. So here, let me make sure I have set up this correctly. Close all my windows here. So I have a database called testdb2, right? And in that database, I have a table called test1. Very simple example, just to demonstrate the point, right? So I have this, it has 4 rows in it, very simple. And then, let me go here to testdb2. And I'm going to do a begin transaction and do an update. So I'm updating C2 equals bogus where C1 equals 2, right? I'm doing a transaction, so I'm opening up a transaction. So I run this update. So this transaction is still open, right? So I come back to my other query. This is my other query window, and I do a select star from the table where C1 equals 2. Right? So I have a problem, and if I go into activity monitor, look at process, I see that it's blocked, right? So 54 is blocked by 52. So what is 52 doing? So 52 is the update, right? That update is blocking my select. This is my select. So this is your classic blocking problem, right? So I have, imagine that I'm actually, instead of running a very simple update, I'm running a huge batch job, and I still want my readers to be able to select, or vice versa, right? So let's go ahead and roll back this transaction. Okay, and so my select is now successful. So now what I'm going to do is I'm going to actually create a snapshot database on it. Okay, so I create a snapshot. I create a database called testdbsnap, and give it a sparse file. And there's a clause called as snapshot of my source. Okay.
Your source is testdb2.
Yeah.
Or it should be test1. Oh, sorry.
Yeah.
Testdb should be.
Testdb2. The name of the database. The name of the database is testdb2, right? Okay, that's what I have to use. So I created the snapshot. So it now shows up under snapshot databases. So I see that here. I can see my table. This table right here is available, right? So now I'm going to go ahead and create that same blocking. So I'm going to begin this transaction. I'm going to do an update and come back here and do the select. But I'm going to do a select on my snapshot database, not on my source. Okay? And it's successful. So just by creating a snapshot, and snapshot databases don't require the same storage as your production database. Okay, you create the snapshot, you let the query run on the snapshot. So if you have a user that runs this huge batch jobs that's causing you problems, guess what? Just say, hey, before you run that batch job, I'm going to create a database snapshot. You go after that database snapshot and read only against that. And what you have done by that is the nature of that, you're avoiding all the blocking that's happening underneath because the reads are happening through the snapshot. Okay, and again, some of you might have questions on how does it all work, and I'll be happy to talk about it after the break. But if you're interested to know what's going on behind the scenes, we can discuss that. But I just wanted to demonstrate that point to you. Now let's go ahead and do a commit transaction. So I'm going to do a commit tran. Okay, I committed the transaction. Now if I do a select again, it's not reflecting the change, right? And the reason is that snapshots are point in time image of data. Okay? So, does that make sense to you guys? So, again, don't look at snapshots as something that, hey, I don't know how I would use it. If you're having readers and writers as a contention, and I as a general practice always tell customers that, look, if you have batch jobs that do read-only operations, do that against the snapshot. Don't go against the base database. Just as a practice, don't do it, because you never know when you're going to have the problems of this contention, right? So these are the building blocks of the next-gen architecture. You've got to start using these features, and you've got to start implementing that as best practices. That's how the resource governor piece and the snapshot piece are two big ones, and then the partitioning and the compression. Yes?
What about snapshot isolation? Would you ever use that?
Snapshot isolation is used. The challenge with snapshot isolation is that if I am having blocking, which is spread over multiple tables, and it's so dynamic that I really cannot pinpoint who starts and who kind of creates that problem for me. It's more prevalent. That's where snapshot isolation makes sense. Make sure that you understand snapshot isolation adds a lot of overhead. Every time an update runs, the copy of that update row sits in the temp DB, right? There's a lot of I/O cost to it. In this case, what I'm trying to do is, I know these batch jobs runs every so often. And every time they run, I don't want them to interfere with all the OLTP activity that's going on. So what I'm doing is I'm creating a conduit for them. I'm creating a database snapshot and say, hey, go read all the database snapshots from all your data from there, right? A lot of things that are something that's very common in enterprise is that you have OLTP data that needs to be transported into the data warehouse, right? Every organization has a data warehouse where you build your business intelligence solution. That extraction process is a read process, right? So that extraction process can be completely run on a snapshot database. There is no need for you to go to the base database. Because on the base database, you might be running maintenance, you might be running a lot of other things that are going on, right? So, yes. Yes, go ahead.
Snapshot, database snapshot, read only and therefore no locking.
Yes, the snapshot databases are read only, and I can talk about the exactly how it's done after the session. Yes.
And is there much relationship between the time it takes to build a snapshot with the size of the database you're making a snapshot of?
Excellent question. There is no relationship between the size of the underlying database and the time it takes. The snapshots are a point-in-time memory of the logical layout of the database. So it only extent numbers and page numbers and so forth and so on. It's not actual copy of the data. So it's instantaneous. When you create a snapshot, you could have a database that's 10 terabytes, and you can create it right away. Yep.
How do you compare it with running the same statement with no lock?
How do you compare it? No lock is not a comparison. No lock is deprecated. It's gone. It's not something you want to use.
But doesn't that
No, you know that no lock is deprecated, right?
No, not aware. It's an art.
Well, you have it's
Say I change my isolation level because
Yeah.
it's an extraction job. I have complete control over it.
Yeah.
I change the isolation level to read uncommitted.
right.
How does it different than this?
Read uncommitted is giving you uncommitted data, right? I mean, transient data can also be returned as a result. This is giving you committed data, but it's giving you point-in-time committed data. So you always get consistent copy of the data, right? So I don't want to get into a lot of the details. I'll be happy to discuss. Let's move on because I got a few more things that I want to cover, okay? And be happy to take questions. So snapshots. So basically the way it works is, when you create a snapshot, it's not a copy of the data. So that's why it's instantaneous, very fast. But remember, when you do an update, the copy of the update page is then sent to the snapshot. So what it means is that you don't want to keep your snapshots for too long because the disk space is going to grow as the underlying data is changing. Okay? So what typically customers do is when they run this big batch job, they create the snapshot and they drop the snapshot once they're done. So clean up. Okay? Keep your snapshot only active for how long you need it. And by the way, you can create as many snapshots as you want to on the database. Now, here's the first level of architecture. So now we are getting into, if I may, can you hold on to your question? I want to make sure I get to how much time do we have? Anybody?
8 minutes.
Oh, gosh. Okay. So 8 minutes. The great stuff is just coming. Okay, so let me just talk about reference architecture. Here's where the rubber meets the road, right? At the end of the day, what can I take back and start building my architecture on? Here's a very simplistic architecture that we have implemented for a number of customers. And you cannot imagine the level of scalability, performance gains, and high availability these customers have received. So it's a 2-node cluster. Okay. By the way, forget about active-passive. The paradigm shift going forward is everything is active-active, even your DR site. Don't even let anybody tell you active-passive is the way to go. N+1, multi-node active-active clusters, multi-node active-active geographically dispersed clusters is the way to go. Okay, you've got to use every server that's in your environment. Okay, so here I've got 2-node cluster, and this customer had the second node as a passive node and the one node as an active node, and they were running all their OLTP and reporting and extraction on this one node. And guess what? You could literally see the smoke coming out of one node while the other one was just sitting there. I got nothing. I'm waiting for a failover. So wait a minute here. This doesn't make sense. We gotta use that other node. And by the way, without compromising your high availability SLA. Some of you are wondering, hey, wait a minute. I have that second node because I want to protect against failure. Okay? Well, you are protected, so don't worry about it. So what we did is we did real-time database mirroring from node A to node B. Okay? So you have 2 copies of the data, right? And then all the OLTP activity, data loads, data entry, that's your principal site. So if you have an application query that wants real-time access to the data, it can still go to your node 1. Okay? But all these big jobs, the big extraction job, big reports, they're all offloaded to the second node. By doing this, they were at 90% CPU utilization on node 1. The CPU utilization went down less than 30% by just separating the readers and the writers. Okay? And the database mirroring is another one of those features like peer-to-peer replication. Use it. It's very mature, very resilient. We have database mirroring running for customers that run thousands of transactions per minute. Thousands of transactions, and it keeps up real time. Now, obviously, you got to, don't do it over dial-up network. It's not the mirroring problem, right? Make sure you have all the infrastructure into place. But it's a very simplistic view. There's nothing, fancy about here, right? So now, what we had to do is use database snapshot because the mirror copy, you cannot use it for any purposes, right? So you got to create a database snapshot, just like I showed you, on the mirror copy, and then you can do all the reads through the database snapshot. What I'm trying to say is that I've seen many customers do this, some customers do this, but they don't use database snapshots the way I just showed you. So what I'm trying to say is you have a feature, use it. So if you have a blocking issue, database snapshot can alleviate that blocking. You can always do row versioning, but this is a quick way for you to get rid of any type of contention at the table level. Okay? Now, let's go to the architecture reference 1. This is a multi-node cluster. As I said, no active-active, okay? Multi-node active-active cluster. So you will have one node that may be a failover node, but you have multiple nodes that are active. So you have your primary site, which is active, and you have your secondary site that's passive. You're doing log shipping or backup restore or some way to get the data copy to the DR site, to your secondary site. Okay? Seems pretty reasonable, right? That's your reference architecture 1. Very common. People, customers use that today. Now, what I'm now doing is adding virtualization. Why do I need to add virtualization? Remember, we're talking about building reference architecture that accommodate all the limitations we live in. So let's say you have an application that somebody wants to roll out. This is your reference architecture. They say, hey, by the way, this application has some very specific security requirements and patching requirements and blah, 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 and it needs to be isolated. Well, guess what? I can create a virtual machine for it, right? So that's why I need virtualization. So I create VMs, right, within a cluster, and I have the failover capability of a cluster, as well as I have the reliability of a VM as well. So I can isolate those applications using VMs. Now, let's take it to the next level. So you have a business application that requires real-time uptime, real-time availability. It can't go down, even for 5 minutes. Can't go down, right? So that's where I can use vMotion. So now what I've done is, on the same architecture, I have now deployed a VM which is configured with vMotion and live migration. Now, obviously, it has limitations, as I said, only a number of CPUs you could use. So the assumption is the application can run within that limitation, and those limitations are going to be removed, right? But what I'm trying to show is the underlying architecture is not changing. As I am making all these changes, the infrastructure and the design is not changing. It's so flexible. So I can easily, on the same cluster, add another VM that allows me to have live migration. Now, what is the problem with this architecture still? What I don't like is I have that DR side that's passive. Right? I don't like passive. I've got all this infrastructure sitting there. I want to use it. Right? So what's my easy way? Guess what? Database snapshots. So now what I'm going to do is I'm going to take out log shipping. Well, I can still do log shipping if I want to. I can create snapshots on top of it. But I like mirroring. I love it. It works really good. So I'm going to do database mirroring for all my mission critical databases. So I have a copy over there, and I'm going to create database snapshots on my DR side. And guess what? All my reporting is now offloaded to the DR side. Okay? If you want to read data, you want to run reports, you're going to go to my DR side. So now I have changed this to active-active. Okay? Now, let's take it to one level further. So what do I have here? I have a read-only DR side. I want a read-write active side and a read-write DR side. Now we're really stretching, right? Getting nervous? So wait a minute. You want to keep our jobs here. Come on. What are you doing? Okay? But I want to take it to a point where I can have an application database that's read-write on the DR and it's read-write on OLTP. I do that through peer-to-peer replication. Okay? So with peer-to-peer replication, what I do is I have an application that's hitting my DR side, and I have some criteria, right? If a user belongs to East region or a user belongs to this department, it goes to my DR side. If a user belongs to this department, it goes to my primary side. And as the databases are changing, they're replicating bidirectionally. So I have the same exact copy of the database. So see what I'm talking about here? So underlying the framework, the investment you're going to make in the infrastructure is not going to change. You're going to leverage that investment to keep building the architecture, taking it to the next level, and that's exactly what I want you to take away from this session. Okay? It's not about an application and a database and a server. It's about what is the design, what is the architecture that is highly scalable, highly available, and it accommodates all these different limitations you have in the real world with the business and the applications. Does that make sense? All right, so I have some slides on backup compression and some other things. I don't know if you guys are interested in that, but I'll be open for a question for lack of time. Yes?
I think you've got 15 more minutes.
Oh, we have time?
Yeah, that's.
Yeah, 15.
Okay, good. I don't know why I was rushing. Anyway, let me go back here. Does this make sense to you guys? You guys have any questions on this? Yes, please.
How many transactions per second can you do on this kind of active?
Okay, so good question. So the customer example that I'm looking at, which had 90% CPU utilization, they were doing about maybe 1,200 transactions per second. When we offloaded all of this, they were hitting 2,500 to 3,000 transactions. So we literally doubled the amount of transaction. And by the way, remember, no app change, no SQL Server change, no hardware was added. It was the exact same hardware they had, and we doubled the capacity by implementing the architecture. Okay, so the point again is the shift in paradigm is it's not the database, it's not the app, it's the design and the architecture. You've got to start thinking about solving problems from an architecture perspective. Does that answer your question? Yes.
How do you avoid split writing? So do you rely on data access layers to avoid both of the service requests?
How do you avoid split brains? Very good questions. So that can be a little bit challenging, right? So the best thing to do is to make sure that you don't have conflicts. Okay, that's the best thing to do. But you cannot avoid conflicts. Occasionally you will have it. And this was the problem and feedback to Microsoft that we gave, say, look, you have this great feature, we can't use it because we can't do conflict resolution. So even if there's one transaction that is occurring on two different places, you got a problem, right? So now we have a conflict resolution. So the transaction is going to be handled. But I think you're talking about split brain in the sense of who's primary and who's secondary.
Right. So if PeertoPeer fails and they're both still up the service request, how do you reinitialize them? Which one's the authoritative copy?
Oh, okay. So if the connection between the two fails, basically all the connections, the users are still going to their own site because you have a data access framework that tells where the user should go, and the transactions are basically backlogged in the transaction log. So when the connection is restored, so there's no split brain scenario here. So if both are active, they're servicing whoever they're servicing. When the link is established, the transactions are then pushed and everything gets synchronized. Okay?
So how do you differentiate the traffic between this side and that side? Have you made any, do you need to make any application change for that? Or otherwise you'll have a lot of conflicts on a high volume.
There's no need to do any application change. What is required is you need to have some logic in the data access framework. By the way, guys, I know some of you may want to leave early. Please make sure you fill out this survey and drop it off at the back box over there. The answer is basically that as long as your data access framework handles how the traffic is where it's routed, you're in good shape. There's really no issue. Yep.
I'm trying to confirm I understand this. So if you create a mirror, by default you won't be able to do anything to the mirror database.
Correct.
Except that you can create a snapshot and do recovery against the snapshot.
Yep.
And so now the next question is you can do all kinds of ad hoc queries by creating a snapshot, do the query, and drop the snapshot. Can we extend this to support like ongoing read query?
Ongoing read queries?
Yeah, ongoing read queries.
You mean real-time read queries?
Real-time read
Oh, excellent question. Okay, so we have a solution to that. So let me ask you a question. What is real-time for you guys? What is real-time?
To a second. To a millisecond.
Second. I mean, can you really, if I even went to the same database, my OLTP database, can you really guarantee a 1 second delay in data? If you are blocked,
It's not a real-time operating system.
Well, if you're blocked, then you're delayed in your data, right? For example, if you have a disk I/O problem, contention. So the idea of real-time is very generic, right? So the way we achieve, you ask a very good question. So the way we achieve that, we actually have this deployed to a customer. We have two jobs on the second server. We have one job that creates a snapshot every 1 minute. Now, if you have because SQL Server agent, the minimum granularity of a job scheduler is you can have recurring or you can have every 1 minute. But if you have other schedulers, you can have a database snapshot created every 10 seconds or 20 seconds, right? So the application needs to make one change. So when the report runs, the report has to go against the latest version of the snapshot. What does that mean? It has to go to the database snapshot that has the latest timestamp. Okay? Now, there's a second job, and the second job basically is a cleanup job. So what it does, it goes through all the database snapshots and say, if there's no active user, I'm going to delete it. I'm going to drop that database. So that's how we provide real-time reporting, close to real-time, okay, on the database. And if you want more details on it, send me an email and I'll provide you.
So it's a real-life example, right?
Yes, absolutely. Yep. Yeah, question? Yeah, you there? Is the data access framework a single point of failure? It could be, but typically you want to have multiple copies of whatever your file is. Like if it's an XML file or if it's a table, you will have multiple copies of it. So if one is not available, you can access the second one. So you have to build a redundant copy to avoid being a single point of failure. But it could be. Yes.
Just one comment. I think the implication here is licensing. Because if you're going to convert to active-active, of course, you need to make sure you have licensing in place for the active.
Yes.
Right?
Yes.
So, but that's not really my question. My question is, on a virtualized environment, I'm new into that. So how do you configure it? You configure it so this node over here is going to be your, if it's a failover cluster, if it dies, I guess this virtual machine is going to shift to this other node over here. I mean, how does it work? I mean, I know in clustering it goes to the other, but in virtualization, how does it work?
So in virtualization, you can actually configure. If you're using VMware, if you're using Hyper-V, you can actually configure the failover process, or which node it needs to get failover. It's a configuration property that's given through the management tool utility. So VMware has its own, and Hyper-V has its own. So it's configurable. I mean, if you're worried about, okay, what happens if the node goes down, then obviously that VM is a resource. It'll be restarted, right, automatically. But if the node is still up and the VM is the only thing that goes down, right, then the VM manager has to manage that failover. Make sense?
For this system,
yes.
You are using at the depth level, you are trying to say that where the load balancing is happening. Why not at the web layer? Rather than web have the web on this side, the other web on the other side.
So why not do the load balancing at the web layer? Anybody wants to answer that? Anybody has any thoughts on it? Good question. So why are we adding this whole complexity on data access framework? Well, the web layer is, think of the big five. You know, it's a police, it's a cop that sends the traffic to different directions, right? But I want a little bit more information. I want that load balancer to be a little bit more intelligent from a SQL perspective. So, for example, I want to know, where the connection is originating from or what the user is. So, if you're using very rudimentary ways to traffic your connections, you can use a load balancer at the web layer. Absolutely, you don't need the data access.
Graphical location, based on IP, you can figure out graphical location.
Yeah, you could do that.
Web layer.
You can do that. If I want to go to the next level where I want to know, for example, if I want to know, what username it's connecting from, what default database it's going to go into, because some applications touch multiple databases, So in that case, I will need some level of data access framework, right?
Why I asked this, because there is a customer sitting in India and there is a customer sitting in US.
Yes.
Right. If he goes to, say, our data center is in India and US. If he goes every time, if he goes from India, the web servers are supposed located in the US. And what we are waiting is that the whole, basically, latency which is introduced by coming there. But we know that there's a data center here, and my 30% customers are here. Because this is the one concept which we are looking at right now.
Yeah, so this actually accomplishes that, right? So you may have your site B closer to India to service those customers, and you may have a site in Europe closer to a data center in Europe that's closer to those users. But those sites are still acting as backups for each other, right? DR for each other.
That's fine, but your web layer is always in US. You always have that latency. Whenever the Indian guy tries, you have to go to US.
I think there's some. I know what you're saying. I think there's some ways to, get over that exact problem. But about not having to make the hop to US and then and I can get you more details if you're interested.
To use F5 to do that load balancing.
Yeah, F5 is pretty good. That's pretty much
Yeah, a couple questions. What kind of latency do you experience between using the peer-to-peer?
The latency depends on many factors. The idea is to keep it as close to real time as possible, but the connectivity is most important.
Bandwidth between the two sites can be very high, right?
Yeah.
Second, how do you handle the auto-generated primary keys? Because if there's insert on this one, insert on this one on the same table, if you don't segment the primary keys, and they may conflict, right?
Yeah, I mean, obviously, if you're the idea is that if you are separating the inserts by geographic location, then you don't worry about primary key because
auto-generated like identity or identity field.
If it is auto-generated, then you will need to have site 1 that is from 1 to 10 million, and then site 2 from 10 million to something else. So that's something you have to. By the way, I have some things on compression and backup compression that I want to just mention to you guys. How many of you are using backup compression? Okay, it's very, very good. You can reduce the size of your backup significantly and save storage. At the same time, and make sure that CPU utilization is going to go up. Same thing with data compression. How many of you use in data compression? Data compression is excellent, excellent. Use data compression. The only thing with data compression, the overhead is that it increases your CPU utilization. So don't do data compression if you're already at 90% CPU, okay? That's not good. But if you are at 40%, 30% use data compression, it will significantly increase your query performance. The I/O cost goes down, memory usage goes down, and if you're using on top of partitioning, it's excellent. By the way, I want to thank everybody for being here. So I appreciate your time. And I have some business cards. If you want to take my business card and send me an email for any references, I'll be happy to provide you.
And I have a quick question.
Yes.
All these features are enterprise edition, right?